All right. 11.3, outcomes per trial to the exponent number of trials is the title. Lots of the time I'm just going to title the notes the actual method that we are going to be using. So the question says, if we flip a coin, so the first thing I'm going to do, I have a coin, and I'm going to say what I know about a coin, and I know I've got heads and tails. That's it. So the question says, if you flip a coin 3 times, what is the total number of outcomes? Well, let's try what we learned in 11.1, the fundamental counting principle. So I'm flipping a coin 3 times, blank, comma, blank, comma, blank. And how many different outcomes do I have for each? Well, the first one I can get a head or a tail, and that's 2 outcomes. And the second one I can get a head or a tail, and that's 2 outcomes. And the third one I can get a head or a tail, and that's 2 outcomes. And I know that the fundamental counting principle says that I can multiply my answers to get 2 times 2 times 2 is 8, which means I can get 8 total outcomes. Now, what does that mean? And in the question it says draw a tree diagram to confirm. But before that, we're just going to learn the formula. So the formula is outcomes per trial to the exponent number of trials. Now, don't get confused with the outcomes per trial to the exponent number of trials. Outcomes per trial is heads or tails, which is 2 outcomes per trial. The number of trials is 3 coin tosses, and 2 to the 3 is also equal to 8. So now we have 2 different ways to do this question. We can use the fundamental counting principle from 11.1, and also this new formula that I'm going to explain further on our formula sheet, outcomes per trial to the exponent number of trials. Now, what if I decided to draw a tree diagram? Now, this one's going to get a little bit messy. As you can see, it's done pretty casually in the notes, but I can get a head or a tail, and then 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 a head or a tail. 3 tosses. So the tree will be 3 branches deep. And then each of my outcomes is heads, 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 or following the second pathway is heads, heads, tails, or following the third pathway, and so on, is heads, tails, heads, then heads, tails, tails, then tails, heads, heads, then tails, 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 then tails, tails, heads, then tails, tails, tails. I should have lined that up a little bit better so it actually works out where all of the final works out all nice inside. But if you count those up, that is 8 total different outcomes. And we were insinuating in this question that it was different, that we got 2 heads and a tail, or a tail and 2 heads, or a head and a tail and a head, which is always still 2 heads and a tail. But we decided that, I guess, order matters, and that's going to be something we're going to consider in the future. So next question. If a test has 10 true and false questions, how many answer keys are possible? Well, that's true or false. So that's 2 outcomes per trial, and it's 10 questions. So to the 10, and 2 to the 10 is 1,024. Next example, if a test has A, B, C, D multiple choice answers with 6 questions, how many answer keys are possible? Well, outcomes per trial, we have A, B, C, or D. So 4 to the 6 questions equals 4,096. Last question on the page. If a family has 8 children, what is the number of combinations of boys and girls? Well, that is, we can have a boy or a girl, so that's 2 outcomes, And if we have 8 children, that's 2 to the 8, which is 256. Now, this is where people are going to argue a little bit. Well, is it different to have a boy and then a girl, or a girl and then a boy? Well, some people would argue that, yeah, it's totally different to have an older boy and a younger girl, or vice versa. So again, order matters is going to be a huge thing that we talk about. So now we have fundamental counting principle, at the top, FCP. Fundamental counting principle, I'm putting that in red. I'm putting that in big red at the top. Fundamental counting principle, So we have the fundamental counting principle. We have outcomes per trial to the exponent number of trials. And now we have our tree diagram. Lots of different methods. We're going to learn a few more.